So we're going to be adding or subtracting rational expressions with unlike denominators here, and the process is to first find the least common denominator of each expression. Second, rewrite each expression as needed as an equivalent expression with the least common denominator that we just found. 3, add or subtract the numerators expressed over that common denominator. And then lastly, 4, simplify, or in other words, write in the lowest terms. So our first example here, A, looks like addition. There's a plus sign between these. And the denominators are not the same. So first, we're going to find a least common denominator. So 8 is 2 times 2 times 2, and 10 is 2 times 5. So we need 3 2's at most, and 1 5 for the number factors, and we need x with the highest exponent. So our least common denominator is going to be 40x squared. Neither one of those expressions has a 40x squared in the denominator, so we're going to have to create the equivalent expressions that do have that. So let's start with 5 over 8x. We need 40x squared in the denominator. So that means we need a factor of 5 and a factor of x. So we'll multiply that to the numerator as well to get 25x as our numerator for this equivalent expression. Then we want to do the same thing for the 11 over 10x squared. We need to have 40x squared in the denominator. So that means x squared is fine, but we need a factor of 4. So if we multiply that to the numerator as well, we get an equivalent expression of 44 over 40x squared. So now that we have the same denominator, 40x squared, that stays, and we're just going to combine the numerators. So 25x plus 44. Awesome. And the last step then. Let's see if we can simplify this. So there's more than one term. Let's lock it up. Is there a common factor for these two terms? Well, 44 is 2 and 11, and 25 is 5 times 5. So they don't share any factors. We don't have a GCF. The exponent is 1, so that doesn't actually factor. And that means that is as simple as it gets for that sum. Then example B, we have 10x over x squared minus 9, and we're going to subtract here. So first thing we need to do is find a least common denominator. So that means we're going to have to completely factor this, x squared minus 9. And that is a difference of two perfect squares, so we'll have an x plus 3 and an x minus 3 as those factors. Awesome. So then I need an x plus 3, and that appears one time in that denominator, one time in that denominator, at most one time. And then I need an x minus 3. So the least common denominator is going to be x plus 3, x minus 3. And that first expression already has that as the denominator, right? It's the same thing, so that stays the same. The second one, however, does not have that denominator. It only has one of those factors. So we need an equivalent expression that has the denominator that we want, x plus 3, x minus 3. So that means we need a factor of x minus 3. That's the only one we don't have yet. So let's multiply that to the numerator as well. And we don't need to distribute here. And I'll tell you why when we get to that part. All right. So now we have the same denominator, and it stays x plus 3, x minus 3. We just need to subtract the numerators. Okay, so 10x minus 5 times x minus 3. So here's the reason why I did not distribute, because if I did, then I would also have to distribute the subtraction. So in this way, I'm distributing both the subtraction and the 5 at the same time, and that just saves me another step. So just makes this less work for me. All right, so 10x, now I'm going to distribute the minus 5. So minus 5x, and another term, that's going to be plus 15. Awesome. Do I have like terms here that I can go ahead and combine? So if I add those together, 10 minus 5 is, I'll put it down here, 5x's all together. And surely I'm done, right? No, because now I need to see if I can simplify this expression. So I'm going to see if I can factor the numerator. Is there a common factor here? Yes. There's a common factor of 5, so I'm going to factor that out, divide to see what remains. And in that case, that's going to be an x plus 3. And then I'm going to see if I can divide factors. So, yep, looks like we can divide that x plus 3. And that's going to make that just 5 in the numerator and just x minus 3 in the denominator. And so I don't need the parentheses because that's all that we have. There's no other factors there, so I can remove the parentheses. So 5 over x minus 3 is my simplified difference there. Some other examples we have here, see some rational expressions. So the first thing that we need is a least common denominator. Okay, more than one term, lock it up. So in my first denominator, I have a factor of 7 at most one time, a factor of x at most one time, and then x plus 1 is unique. I don't have that yet, so I need that one time. So that's going to be our least common denominator, and that means we're going to need some equivalent expressions that have that denominator, because neither of these do. So let's start with the first expression. 5 over 7x, I need to have 7x times x plus 1. So I'm missing a factor of x plus 1. Let's multiply that to both the numerator and the denominator. And since this is the first term in the sum, I'm just going to go ahead and distribute. So 5 times x is 5x, and 5 times 1 is 5. So we have 5x plus 5. Then the second expression, we need to get 7x, x plus 1 in the denominator. So we don't have the 7 or the x factor. Let's multiply that to the numerator and denominator. So 2 times 7 is 14 times x. All right. Now that we have this, and I'm just going to bring it down here, we have the denominator that stays the same. And then we're going to combine the numerators. So 5x plus 5 plus 14x. Okay. And we have like terms, so we can combine those. So let's do that first. 5 plus 14. That's 19x's altogether. And can we factor that? 19 is a prime number, and this is not going to factor. So that means I just need to get rid of the parentheses to complete my answer here. So I'm going to have to distribute that denominator. Sometimes in the homework program, they don't care if you do this or not. But if it says simplify, which it always does, it's implied, then you always want to remove the parentheses. So 7x times x is 7x squared, and times 1, that's going to stay the same. So that'll be our simplified sum for this problem. Ooh, D is interesting. Let's see. We want to find the least common denominator here of x minus 6 and 6 minus x. And if you want to take the product, you can look at those as unique. Or you can look at this as, let's switch these terms, because in polynomials, I want them to be in the descending order. So let me do that. Factor out a negative, and that's going to change those signs. So then look, we only have one x minus 6 factor. That's all we need, but we also need a negative then. which is very important. If there is a negative, your LCD should have a negative so that these can be exactly the same denominator. And so neither one of these, or actually this one does have the denominator that we want. So let's write it here. Negative x minus 6 is the denominator that we want for both of these expressions. And this one does have that, so 15 is fine. The other expression does not have the negative, though, so I can multiply by -1, right? If I multiply -1 to the numerator, multiply -1 to the denominator, then I have -10 here. So now I have the same denominator, and it stays. I just need to combine the numerators, so -10 minus 15. And -10 minus 15 is -25. And then you'll see that we can divide that -1 from both the numerator and denominator. So that leaves us positive 25 and positive x minus 6. That'll be our simplified difference here. Example E looks a little tricky because 2 is not a rational expression, but we can make it into 1 by just putting it over 1 because all integers are rational numbers. And so when we're looking for the least common denominator, we only need the other denominator because 1 is an identity in multiplication. So we want to have x plus 5 for both of these denominators here. And this one already has it, so it stays the same. However, 2 needs to be changed so that it has the denominator that we want. So we're going to need an x plus 5 factor. We'll multiply to both the numerator and the denominator. So we distribute 2 times x is 2x, and 2 times 5 is 10. So now we have our equivalent expressions here. And so the denominator stays the same. Then we just need to add the numerators. So 2x plus 10 plus x. Like terms, we can add those together. So 2x plus x is 3x altogether. Then we want to see if we can factor and divide factors. But there's no common factor, and it's degree 1, so we're done. And then I'm just going to take off the parentheses in the denominator because that's not needed anymore. Once we know that's the only factor, then those terms are free. For example F, then we want to go for a least common denominator here. So more than one term, I'm locking those into factors. And then I need to factor in order to see what factors we're working with. So I need to unfoil this trinomial. Factors of x squared and factors of 4. Probably 2x, same sign, both positive. So yep, that works. So it looks like we have 2 factors of x plus 2 here. Then x squared minus 4. That is a difference of 2 perfect squares, so we're going to have the sum and difference factors of x and 2. So we need an x plus 2, and that appears at most 2 times, so I need 2 factors of that, so that takes care of that one. And this is unique, x minus 2, I'm going to need one of those too. So we need to get equivalent expressions that have 2x plus 2 factors and 1x minus 2 factor. Okay, so let's start with the first expression, 6x over x plus 2, x plus 2. We need to get x plus 2, x plus 2, x minus 2 in the denominator. So that means we need the x minus 2. We don't have that factor yet. we need that here. So let's go ahead and distribute. So 6x times x is 6x squared. And 6x times negative 2 is minus 12x. So we have our equivalent expression for the first expression. Now I need to work on the second expression. We have x over x plus 2x minus 2. And we need to have 2x plus 2's and 1x minus 2. So we already have one of each. We need one more x plus 2 factor for this denominator, which means got to multiply the same thing to the numerator. So you don't have to distribute, on the second term if you don't want to, but this is addition, so it's not going to make any difference. I'm going to go ahead and distribute at this point. So x times x is x squared, and x times 2 is 2x. So that's what we have for the numerator of that second expression. So I'm going to bring that over this way. Denominator stays the same. Right? We go through all that trouble to get it, it better stay the same. The numerator now is going to be the combination of all of these terms. So 6x squared minus 12x plus x squared plus 2. X. Oops, I missed that somehow. It's right here, so definitely that's part of it, 2x. Okay. All right. Denominator stays the same. Let's see what we can do to simplify the numerator. So like terms, 6x squared plus 1x squared is 7x squared. And 12x, a negative 12x plus 2x, that's going to be minus 10x's altogether. And finally, now we can see if we can simplify by factoring. So there is actually a GCF here. Let's see if it makes any difference. Just x. So if I were to factor out that x, that'd be 7x minus 10, which is not in any of these denominators. So that is not going to help us out. So let me just backtrack. No need to factor because it's not going to divide. So let me expand everything then. Now that I know this is as simple as it gets, I gotta multiply these out. This is the point where I would say, you have 3 factors, you probably don't want to do that. Should I leave them? I'm just gonna do them, but you don't have to because it's quite complicated. So we've got an x plus 2, and I'm going to multiply this because it's a difference of 2. It's a sum and difference, so that'll be x squared minus 4. And then I just need to go ahead and FOIL this out. So x times x squared is x cubed minus 4x plus 2x squared minus 8. So that'll be x cubed plus 2x squared minus 4x, minus 8. And that is the simplified sum for those rational expressions there.